Hey guys, in this video I am going to go over the two examples that was attached as a PDF. So if you didn't do those yet, I would recommend you do those before I go over them, okay? So I'm going to go through them because there's going to be a quiz tomorrow and you're going to have a couple problems like this. So these are questions that are modeling, AP-like questions. And the first one gives us a differential equation and then asks which are solutions. So as you think about our differential equations, some of them, like if you had sine, I know the derivative is going to be the cosine, and then it's going to keep switching back and forth. I know that the e to the x comes out to be similar to itself, so I'm actually going to go to the second one, because what I notice over here is it's one only, or two. I want to really check 2 and 3 based on how they wrote those solutions. So I'm going to go to the second one. And for the second one, I'm going to check to see if it's a solution. So in order to do that, I need to take the second derivative and the first derivative. So 3 e to the 2x times 2. And then the second derivative is 6 times e to the 2x times 2, or 12 e to the 2x. So now I'm going to go to this equation, this differential equation, and sub those in. Okay, so I'm going to take 12 e to the negative 2x minus 6 times y prime, 6e to the 2x, plus 8 times y, which is the original, 3e to the 2x, and see if that gives me a true statement. Remember, if it's a solution, it's going to give a true statement. So I have 12 e to the negative 2x minus 36 e to the 2x. I don't know why I made that a negative. That's positive. Here and here. Okay, plus 24 e to the 2x. So 12 plus 24 is 36 e to the 2x minus 36 e to the 2x. That works. So now I can eliminate A and C. So now I need to try the third one. I don't have to try the first one at all. So the third one looks pretty similar to what we just did. So I'm going to take the first derivative, c e to the 4x times 4. Then I'm going to take the second derivative, 4c e to the 4x times 4. And I can see that this is very similar to that last one, so I think this one may work out. So going through and checking that, the second derivative is 16c e to the 4x minus 6 times y prime 4c e to the 4x plus 8 times the original. And I want to see if that's equal to 0. So I have 16 plus 8 is 24 minus 24. That also works. So my answer is answer D. Okay, the next one for what value of k, if any, is y equal to e to the negative 2x plus k e to the 4x, a solution to the differential equation. So again, I want to go through and work on this differential equation. So in order to do that, I need to find the derivative, actually the second derivative. So of course I have to find the first one first. And then the second one. And then what I'm going to do is go and put everything back into that differential equation. So y minus 1/4 of y double prime and I want to say, is that equal to 5e to the 4x? Now, as I do this, I'm hoping some things cancel out. And you can see those e to the negative 2x's due. So I have 1k e to the 4x minus 4k e to the 4x, which is negative 3k e to the 4x. Now when I set this equal, you'll see that the e to the 4x is the same on both sides, so we need negative 3k to equal 5, so we can get our answer of negative 5/3.